Hi everyone. My name is David. I am a software engineer. I currently work at MemSQL, where I help build a really fast, high-performance distributed SQL database. Has anybody heard about us before? No? You have? Really? We are based in SF, and I actually work remotely right now. Today's talk will be about reasons interoperability with JavaScript. By reason, I actually mean Bucklescript because reason is just a syntax, so all the interop lives in the Bucklescript compiler. And by interop, all I really mean is just how code that gets compiled via Bucklescript can integrate and interact with existing JavaScript code, existing JavaScript libraries, and the entire JavaScript ecosystem. Why is this relevant? Well, it's really important because if you're writing a reason application, such as a tic-tac-toe game, chances are you're going to need to use some library that was written in JavaScript. There's like over 600,000 packages on NPM. There's a really good chance you're going to want to use a few of those when writing reason. And for a lot of them, there's already bindings like reason React for React, but for a lot of them, there aren't bindings yet, and you're going to have to write them yourself. So it's really important to understand how the interop system works. The first thing I want to teach you guys about the interop is the raw operator.
Yes.
It's great. It looks dumb, but it's great. It allows you to basically just take in JavaScript and put it in the middle of your reason program. So if you're writing reason and maybe you've never written in a strongly typed system language before, maybe you're struggling with OCaml, you're in a rush. You just take some JavaScript node, some JavaScript code. You know how to write JavaScript. You take it, you put it in your reason program, and that's it. The second one is actually very interesting. It takes an expression. This is actually a multi-line string, by the way, this syntax. It takes a JavaScript expression and it saves it into a reason variable, which you can then use like any other reason variable. Of course, this is not type safe. Bucklescript has no way of knowing what the type of add is. And so you could just as well do add plus 8, which means like, I don't know. And so if you do stuff like this, you're basically just writing JavaScript again. You can do it in a little better way. You can annotate your raw JavaScript code. So here I actually have more type safetiness in that I can only call add with 2 integer arguments. But we can make it even better. We can declare a proper FFI, a foreign function interface, that basically allows us to map reason to JavaScript in a more declarative and easier to think about way. And this is how you do it. So first of all, I think somebody in the audience came from OCaml or had experience with OCaml. If you've ever used OCaml, this syntax might just look similar because it's the same syntax that the OCaml compiler uses for people to write C language bindings. And so that's pretty cool because we're using a true and tested method of writing an FFI. In this case, in this example, I'm simply writing a binding for the math.sqrt function in JavaScript. I use the external keyword for doing things like that. I give it a name, in this case sqrt, and I tell Bucklescript that the type of my value is float to float. I use the bs.val attribute or operator for specifying that this binding is a value. It can be a function, it can be an int, it can be a string, it's a value. And then I can call sqrt like I would call any reason function. And similar to this bs.val operator or attribute, there's a ton of other operators that you can use for binding to different things. I'm not going to go through all of them because that would be really boring. I'm just going to mention a few of them, and then we're going to look at an example. So there's bs.new that allows you to create bindings for the creation of a new instance of an object in JavaScript. There's bs.val, we already mentioned that. There's bs.send, which allows you to write bindings for a method on an object. There's bs.obj, which allows you to create JavaScript objects from labeled arguments. And there's bs.splice, which allows you to create functions or write bindings for functions that have an unknown number of same type arguments, which is actually not easily doable with OCaml. So that's pretty cool. Now, let's go through a real life use case of writing bindings for an existing JavaScript library. I chose Luxon. Has anybody heard of Luxon before? It's written by the same team that wrote Moment.js. You guys have heard of Moment.js, right? It's a very popular daytime handling library. Luxon is different. It's more like DataFNS in that its API is immutable, more functional, and actually chainable. And this is the example that Luxon has on their GitHub page. And so we're going to do a little exercise here. We're going to write bindings for all of those functions and then recreate this very same example, but instead of in JavaScript, we're going to do it in Reason, just to see what it looks like. So first of all, let's think about what's happening here in Luxon. We're using the datetime.local constructor to create a new datetime object representing the current time. We're then setting its time zone to the New York time zone. We're subtracting a week, and then we're jumping to the end of the day. So like 11:59:99 9999 p.m., which is something you might want to do when working with dates. I don't know. So writing the binding for the local function is actually very simple. Local is a simple function that takes no arguments and returns a datetime type. In this case, I declared an abstract type at the top called DT, short for datetime, which doesn't actually have any properties, but it doesn't need to have any properties. It just needs to exist, sort of. And then I tell Bucklescript that the JavaScript matching code for local is local, but I could actually have empty quotes, and Bucklescript would know to use the variable name. And from now on, I'm going to do that. And the only thing we also need is the BS attributes. So in this case, we're using bs.val because local is a value. We're using bs.scope because local is a value in a global object called datetime, as we saw in the JavaScript example. And we're using bs.module because this datetime global object actually lives inside a module that has to be imported. And once we do that, now we can actually use local like any other reason function, as we can see here. And if you're confused, maybe looking at the generated code for this is going to help. This is the generated code by Bucklescript for this exact file. It's just imports the library, and then it doesn't actually create any local functions. It just replaces every usage of the local function by its equivalent JavaScript code. So here, when I do let my date equals local, it is actually just calling luxon.datetime.local. Did that make sense? Does anyone have any questions so far? Straightforward. Okay, cool. So now, I actually don't know what happened. Let's take a look at the second method here, setZone. It's a method or function that is applied on a datetime object, right? Its only argument is a string, and its return type is, once again, datetime object type. So to create a binding for it, we use the bs.send.pipe attribute. I told you before that bs.send was used for creating bindings to methods on an object. bs.send.pipe is used for the same thing, except it puts the main argument of the function or of the method at the end, which is more OCaml-y. It's more in the way of doing things in OCaml, but most importantly, it allows us to use the reverse function operator. I don't think the reverse function operator was introduced before. It basically, I think the best way to explain it actually is to just open refmt or retop and just.
Can you zoom in?
Yeah, sorry guys, and actually look at what it means. I'm pretty sure we can do this. I think this was in a blog post by Axel. I'm not sure. You did this maybe, and we can actually see what the pipe operation does. It takes some argument a function that takes an generic argument of type A and returns some generic argument of type B, and then it returns generic argument of type B. So basically, what it's doing is it's calling a function in the reverse order, and that's actually what we need here. Setzone, as declared by the Bucklescript bindings, is of type string, datetime to datetime, because I used the .pipe. And so when I use the pipe operator, I actually get proper chaining in that the output of local is passed to setzone as the last argument transparently by OCaml. I don't have to do it myself. The pipe operator does it for me. It takes the output of local and passes it to setzone as the last argument. Did that make sense? Go ahead.
Do you know the reasoning why the pipe operator does not insert it as the first parameter like in other languages?
I don't know. Maybe somebody in the audience knows better, but I'm pretty sure it's because in OCaml and because of currying, the last argument is usually the main argument. So that's probably why.
That makes sense.
Carrying and then optional parameters. Yeah, so the rules around carrying and optional parameters.
Yeah, so the idea is that in Haskell, for example, every function is unary, right? Every function takes one argument. So every function that takes two arguments declares a function that takes one argument. So it has to be the last one.
And in Reason, it's actually the same thing. Even though you can declare a function with many arguments, it'll still be, you can still use it as if it was a function that returns a function that returns a function. I'm glad you got it. Let's move on to minus. So minus, also a method applied on a datetime object type. And it also returns a datetime object type. And its argument seems to be some sort of duration represented by a JavaScript object. If we actually look at the documentation for Luxon, duration can be three different types. It can be a number, in which case we're subtracting by a number of milliseconds. It can be an object, like the one we saw, or it could be a duration type object, which is something different that Luxon implements. Variadic type arguments, so an argument that can be of multiple types, is possible using polymorphic variant types. If you want to understand this better, I recommend the documentation or Axel's blog post on variants, which explains this really well. But for the talk, and this is actually what I did when I implemented the bindings for Luxon, which are up on GitHub. But I'm not going to go into that. I'm just going to talk about a simpler way of doing it, which is to declare three different bindings for the three different types of arguments that this function can have. Now notice that in OCaml, there's no method overloading. So you have to give the three different functions three different names, but they all map to the same JavaScript function. For the talk, we're only going to implement the last one because it's the one that we actually need for recreating the example we saw in the beginning. To do that, we have to do something a little tricky. So we have to declare a Bucklescript object, which is also something tricky. And then we have to use the bs.obj attribute that I mentioned before to turn a function that takes labeled arguments into a duration object, which we declared above. Now, labeled arguments, I actually was expecting to not have to explain what they are. Like I was expecting other talks to have it, but it's actually very simple. It's just like optional arguments that can be in any order as you want. So I think in Python there are labeled arguments. I'm not sure what they're called, but it's pretty much the same thing. Except because of currying, I think you also have to put a unit here to basically say that that's the end or something. I'm not really into the details there. And then, just like we did before, we have the minus obj binding declaration of type duration obj to datetime, which maps to minus in JavaScript. And calling it is simple. We just do the same thing as before, but we have to create a duration object using the binding that we declared here. Now, you might think this is ugly. I honestly, I don't like this either. We have repetition here. We have to declare these things here, and there's actually a lot more missing here and here. So if I was writing this library in OCaml, I would just not allow for three different types of arguments. I would just come up with something simpler. Probably if I was writing this library from scratch, I would only have labeled arguments because it's the more OCaml-y way of doing it. But because we're creating bindings for an existing JavaScript library, we have to sometimes make this accommodation so that people who are just converting the JavaScript code to Reason can actually keep their code pretty much the same. And now the final, actually, let's go back. The final method is endoff. Once again, a method on a datetime type object returns a datetime type object, and its only argument is it can be day, it can be month. You're basically jumping to the end of some variable. And in OCaml, we can actually turn this into something better, which is we can use polyvariant types to basically constrain the values that you can pass to this function in a sort of in-ami kind of way, and all we have to do is use the bs.string attribute. So we get compile time verification of the arguments to this function. And even though we are actually writing bindings for a JavaScript library, a JavaScript API, we've already improved the API. This is already better than using the JavaScript API because we will get errors at compile time. So I think this is really cool because we're actually improving an existing API. And then we can look at the final example. And one thing that I think is cool here is that they're actually very similar. And this is one of the selling points of Reason, is that the syntaxes are sort of similar and allow for same kinds of methodologies. And you might notice that American New York here could also be a polyvariant. Yes, it could. I just didn't do it for the talk, but we could definitely do it as well. Any questions on that first example? Yeah.
What are the braces there on the make duration object at the last one? Where are?
Yeah, so basically because it's a labeled argument function, you have, this is also the same in OCaml, you have to signify that these are all the arguments you're sending, because otherwise, if I only passed weeks equals 1, what the type of a make duration object weeks equal 1 would be a function that expects the remaining arguments for currying. Does that make sense?
Okay, you use kind of a label as an end.
Yes, it's like the end, because
It's a convention in
Yeah.
Yeah, you have kind of a conflict if you support both optional parameters or default parameter values and currying or partial application via currying. Then you have to be clear what omitting a parameter means. And with labeled parameters, you have the option you can omit and then it curries. But as soon as the first positional parameter comes, that's when the default parameters get filled in. The defaults get filled in. So that's why I need this mechanism. And if you don't have any positional parameters, you kind of have to make one up. And that's what the unit is for. So if there had been a positional parameter after all the optional parameters, you'd be fine as well. You wouldn't need the unit.
Thank you.
And it's actually, well, in this one case, it's a bit weird, but very often it's not weird, and you get the best of both worlds because you get both currying and optional parameters. So it's actually cool.
I mean, you could go one step further here. You could create a method like make week duration, just pass it one, you know.
Yeah, you could.
You could do that.
You could minus object could be could have label parameters,
Yeah.
and then you just cross out the make duration object, and then it would be a little simpler.
Yeah, so I did that, I think, for the library, and I used shadowing to basically have minus obj as a binding, and then you can redeclare minus obj as a label argument function that calls make your object, and it hides the API from the user. You can do that.
Include in the slides, like as a later before you post them.
Yeah, I'll do that.
This piece of code.
Yeah.
Cool.
Moving on, I want to talk about a second example that makes use of the JS module or the JS API in Bucklescript. The JS module has all kinds of good stuff and helpers for the JavaScript ecosystem. It's where console.log lives, for instance, under js.log. And a lot of other cool stuff and very useful stuff is also there. Now, this is MySQL.js. I'm not sure if anyone has used it. It's a very simple library for interacting with MySQL database. This is their API. You can create a connection and then you can query it. You send in some query string and a callback with error, results, and fields. error is a nullable type. If it's null, the query went fine and you can access results in fields. But if error is an object, or is an error object, then you can actually inspect it. You can use it as you would use any error object. You can throw it, for instance. And I actually wrote bindings for my SQL.js. And at first, I did it like this. So actually here at the top, Axel, this create connection, this is actually the thing I was telling you about that you suggested. This is under the hood. This is creating a connection object, but I hid the create connection object from the API. And this is, by the way, this is not the declaration of the bindings. Obviously, this is just how you would use the bindings that I wrote. And then the query function is very similar to the original MySQL.js function. It receives a query string. Maybe it should have been the last argument. And a callback with error results in fields. And error, instead of being a nullable type, which does not exist in Reason, is an option type. And it can be none, which means there was no error, or it can be some, in which case its argument is the error object. Now, I actually thought this was good enough at first, but it's not. And the problem is, you might have noticed it, is that a client of this library could ignore the error type and simply access results in fields, whether there was an error or not. So this is a problem with the original JavaScript API that they can't handle because of JavaScript, but we're writing reasons so we can do something better. And I then rewrote my bindings to make them look like this. And I think this is better. The callback now only has one argument, which is a result type. And instead of using none sum, I used another construct, another similar variant type, OK and error, to basically force the client of the library to handle both cases. This is actually a good example of taking an existing API and making it better when you're writing Reason. Go ahead.
To be fair, we've had this for some years now with promises, right?
Mm-hmm.
They can be successful or not.
Yeah, exactly.
And they're even asynchronous, and you don't have to nest callbacks and everything.
Mm-hmm.
In the first talk, I think you said that promises and Reason are not that well supported yet. How does that show? I mean, if the MySQL query would return a promise, how would that look?
It's not too bad actually, but for now what you do is you basically have the promise chains, but in the long run, and I think it probably will be based on monads or something, or it might be based on monads, so that's one of the two options. But then you will have syntax that is more similar to async functions, and then will have something really neat.
But I'm glad you brought that up, because actually MySQL.js does not support promises, so I couldn't do that here. However, there is another JavaScript library called MySQL2.js, which does support promises. And while my bindings are against MySQL.js, another member of the community of Reason has written MySQL2 bindings. I just found them out today, and they do use promises, but he's also using something similar to this construct at the same time. So good point. You can check out both BS-MySQL and BS-MySQL2 on GitHub. Now I wanted to also mention the other way around. Axel asked me to research this, and I tried out how you can write Reason code and have JavaScript consume it. I actually thought it was going to be super easy, because if you look at the output of Bucklescript compiled code, it's just normal, readable, sane JavaScript. But there's actually a few caveats that we need to look at. So first, let's look at a simple example. I write this very simple function in Reason that just returns is or are depending on some n number, and this compiles this function with Bucklescript. So first of all, notice the Bucklescript by default will export every single value and every single function that you write, which you can disable that, you can change that, but it's very useful for consuming it with JavaScript. And it creates a function very much like my original function in Reason. Same type, it's a function. Same argument types, it's number. And same output type, a string. So everything just works. I can simply import that function from a generated Bucklescript output, and I can use the function like I would use any JavaScript function. But this isn't always that simple. So let's look at a different kind of example. I wrote this function in Reason. It's a required field validator. You could use it, for instance, on a form. If you have a form and you have a required field, its validate function could be required field validator. It takes a value, which is inferred to a string, and if its length is 0, then you use the option type variant with a string argument on the sum constructor to return field as required. And if it's not 0, then you could return none. Whether you would write this function like this or not is not actually relevant. All I want to show is how you would use this function from JavaScript. And so if you actually try it out, just like naively, try to import the exported function and call it on a valid field, you get back 0. And you might wonder why. Well, this is because Bucklescript doesn't, well, first of all, in JavaScript there are no variants, so it was obviously not going to go right. There is not an easy way to represent variants. Well, there is an easy way to represent variants, or the option type variant anyway, but something weird was always going to happen. And the reason we get 0 is because Bucklescript's internal representation for the option type is 0 when none, and a single element array when the variant type is sum. And here you can see other internal representations. So ints are numbers, int64s are tuple, or an array really in JavaScript. Strings are just strings, tuples are arrays, lists are complicated, and the idea with this slide, there's a lot more types and a lot more weird conversions and a lot more simple conversions, but this is on the Bucklescript manual, by the way, if you want to check it out. The interesting thing here is that you have to be very careful with what you expect things to be. Maybe you would expect lists to be normal arrays. They're not. And more importantly, these representations might change. The reason the Bucklescript engineers warn in their documentation that you should not ever depend on this, because if you depend on this and they change, well, then you've done good, right? But they do provide some API for dealing with this stuff. So there's a function on the js.null namespace in Bucklescript that allows you to convert an option type variant to a nullable JavaScript type. So I could declare some function called required field validator JS. JS just means this is for JS clients of my library and not for the Reason clients of my library. And it's a function that takes a value and returns the from option output of the original Reason function call. And then in JavaScript you can call it, and what it does is it returns null for the none type of the variant, and it returns just the contents of the sum variant type argument. So it does what you would expect from a nullable type, which is useful. Now let's look at another example. Let's say I create a record called person with an age and in the name string. And then I create a function that converts a person record into a string. Remember that this is implicit return, so this thing here is just what I'm returning. The string is just name is age years old, and I'm showing you an example here of how I would call that function. Now, as I believe Marius mentioned before, records are compiled to arrays. So you might just think, oh, I'm going to do this. I'm going to import the person to string function that I declared here. Because records, when compiled, are arrays, I can just do this, which is the way of creating a record in pure JavaScript, and it would work. And yes, it would work, but I do not recommend this because, of course, if the internal representation of record changes, this is going to break. So they actually also have an API for this. You can just prepend your record declaration with bs.deriving JS converter, and it will actually add two functions to the generated Bucklescript file. A person from JS, which I use here, and a person to JS. What they do is sort of obvious. They convert back and forward from the the record representation, which is an array, to a more sane representation with standard JavaScript objects. So I could just write this, or I could add that little thing, that little line to my original example, and then I could simply import the person from JS function and use it as an argument to person to string. So now I want to just go over a few takeaways from my talk, and like if you can forget everything I said until now. This is all that matters. Think twice before you start to bind. I didn't actually say this, I forgot, but you really should make sure you want to create bindings and not create your own reason library. And actually, you should look up existing bindings for the package you're trying to create bindings for. You can use Redux for this, which is the reason package, not package manager, but package
Index
repository. Yeah.
Redux.
Redux.
Yeah.
Redux with an E.
Use that to find existing libraries. Ask on Discord. Discord is great, once again. And secondly, gradually reach full type safetiness. Don't be afraid to start slowly. So back in the beginning, I used that type DT for datetime. I didn't actually add any properties to it. And maybe I should have, maybe I shouldn't. But the point is, you should start with something as simple as you can, and then gradually make it more fully type safe. So you can embed raw JavaScript in your reason. It's fine if you're just starting out, and then later on convert it. This is a popular technique amongst JavaScript to reason rewrites. Thirdly, bindings don't need, and probably shouldn't be, one-to-one mappings to the original API. Reason, or OCaml, is a different language from JavaScript, so you probably shouldn't have the exact same API. There's a lot of cases where you want something different. Fourth, you can and should write tests for bindings. And how do you do it? Well, in the case of Luxon and other bindings out there, you can just take all the original JavaScript tests for the package you're writing bindings to and put them in your repository. So Luxon actually already uses Jest for their unit testing. So what I did is I copied their tests. I used BS Jest, which is a set of Bucklescript bindings for Jest. And I just copied all of their tests. I replicated all of their tests with my bindings API and provided their tests passed against my API. It means that my bindings work. Other people have done this. It's very simple. You probably should use interface files, MLI and REI. I actually haven't tried them out, but other bindings developers have used them to hide the separate the implementation of the bindings or of any library in OCaml really from its actual type signatures. You can expect JavaScript output every now and then. Something that you might think that when you write reason and pass it through Bucklescript, you don't have to care about what Bucklescript generates, and that is true most of the time. But I do think it'll help you a lot to understand how Bucklescript works and how reason is actually working under the hood if you inspect your JavaScript option and verify that it makes sense every now and then. 7, I think writing bindings is a surprisingly great way of learning reason and OCaml. Maybe you think that only by writing a real reason application you're going to learn the language, but writing bindings is actually very useful because it teaches you all of the sound type system things you need to know about OCaml. And finally, having JavaScript clients consume your reason libraries might require some work, and there's a few weird things there. But then again, I don't think this is the primary goal of the Interop system. The Interop system was designed first to make reason able to interop with existing JavaScript libraries, and then second to be able to do the reverse think. But it's still possible, as I showed you in those examples. That's the end of my talk. Thank you very much. I would appreciate any feedback you guys have after the talk or something. Those are my links. Thank you, guys.